7.3 Antidifferentiation by parts. This is a challenging little lesson. It's not the hardest thing I've ever seen, but it takes basically, if you have two functions next to each other, and the AP exam will disguise this question, I'll have examples in class. It says, how would you integrate them? So you look at this, you say, well, isn't, the derivative of x, going to be able to cancel there? Well, no, it's 1. It's not going to cancel. So we're kind of left in a quandary as to how to do this. Well, we're going to have to integrate by parts. Whenever, again, you have two that are being multiplied, natural log of x and x and cosine of x and x squared. We're going to do some complicated problems here, but they can't be done that way in they can't be done that way on the AP test because they would take too long. So a derivative of this is leave it dv dx plus leave it du dx. So then we do something weird and say, well, what if we undo that and integrate them? Well, it's kind of weird because we're going to integrate each one with respect to x. And you look at it and you go, whoa, wait a minute, that doesn't really make any sense. Your dx's cancel here and here. And the integral of derivative cancels, you're just left with u times v equals integral of u dv plus the integral of v du. And then we're going to subtract, excuse me, this one over minus the integral of v dot du. By the way, I have no idea what's happening here. I don't know why I put an F in there. That should be a of v du. So that's gone. And we get this formula, integral of u dv equals uv minus integral of v du. Great, that's just PGP. What are we supposed to do with that? Well, with practice, just like substitution, we will get this and we'll say, well, the first function is x, and notice it's a function and a derivative. We'll call dv cosine of x dx. First question I get is, well, how did you know that? And I say, well, practice. I don't know what else to say. Here we go down with sorry about that, du equals dx with derivative, and here we go back up with an integral. So the integral is sine of x. We don't have to worry about plus c. We'll sort all that out later. Think about it. Derivative of sine of x is cosine of x, and our derivative of u is du dx. Now we get uv, which I do with that x times sine of x, still minus, and now this is where I lose people. They go, well, you didn't really help yourself. You still have an integral to do. Yeah, but I couldn't do this. I can do that. Equals x sine of x minus, in this case, plus cosine of x. Because the integral sine of x, yada, yada, cosine of x. And then, of course, we put a plus c on the end. What just happened? I don't know. Let's find the derivative, see what we get. Derivative of x sine of x will be leave it cosine of x plus derivative 1 sine of x minus sine of x, derivative c is gone, plus sine of x minus sine of x, x cosine of x. That's what we started with. So we have learned how to integrate another different way. We still have one or two more techniques to go. We've done just straight up antiderivative, and we've done u substitution. We're going to do, now we've got an integration by parts. We're going to do separation of variables, and we're going to do by partial fractions. So now we got a tough one on our hands. Find the integral of x squared e to the x dx. So practice makes perfect. I think we want to do this. So we get x squared e to the x minus integral 2x e to the x dx. Very important I put the dx here. So again, we circle that way minus that way. I can't integrate that. Gotta be really, really, really careful now with the negatives. I'm gonna put the 2 out front, minus 2, and I'm gonna block that out. Let's do it again. I put the 2 and negative out of here, so it's just positive now. U equals x, dv equals ex dx, du equals dx, v equals e to the x. This one, x e to the x minus this one, e to the x dx. This bothers me, so I'm just looking at it for a second. Yeah, I guess that's it. That makes sense. All right. Equals x squared e to the x minus 2. This is fine. Minus e to the x plus c equals x squared e to the x minus 2x e to the x plus 2 e to the x plus c. Before I check my work by taking the derivative, if you want to, you're more than welcome to. I'll pass. So let's see what's going on. We have e to the x, we have trig. We're also going to have ln of x. Which one we use when is very tricky until you've practiced a lot, then it's not so bad. So here we go. Solve this differential equation with the initial condition. Y equals -1 when x equals 1. Now I can plug this in, go from 1 to x and plug -1 at the end, which I think I will. No, I'll just do it with the plus c and then I'll blast them all out a long way since we can take the integral of this. So the integral of dy dx with respect to x is the integral of x ln of x dx. Temptation, u equals x, and off we go. I'm going to try u equals ln of x. How could I possibly know that? Practice. V equals x squared over 2 du. I don't know why I underlined that. Equals 1 over x dx. Equals x to the third over 2. Nope, that's wrong. Why did I get that's so weird? Equals, so weird. X squared ln of x over 2 should be an absolute value here. Yeah, let's put it in. Couldn't hurt. No, that was part of the problem. So no absolute value there. Minus the integral of x squared over x is x over 2 dx. Plus c, we might as well get that in there now. Equals x squared ln of x over 2, add 1 minus x squared over 4 plus c. And that's y. Integral dy, because these are going to cancel, is just y. Oh, by the way, -1 equals 1 squared ln of 1 over 2, 0, minus 1/4 plus c. Add 1/4, I get -3/4. Yeah, I'm not even sure how we do that, plugging that in the other way. So let's not do that. Y equals x squared ln of x over 2 minus x squared over 4 minus 3/4. Cool. So you notice anything about all the integrals we've taken so far, right? We've had polynomial. We've had e to the x. We've had some trig, sine and cosine. So that's where you're going to see these problems the most. All right. And notice that we learned, okay, if we have an ln of x, make that our u value. Ooh, now we've got e to the x cosine of x. This one I remember specifically doing in high school and being like, what just happened? So this is going to be weird. Be prepared. u equals e to the x, dv equals cosine of x dx, du equals e to the x dx, v equals sine of x. We get e to the x sine of x minus integral e to the x sine of x dx, at which point you might say, this is going to oscillate forever. There's no getting rid of it. And I would say, you're correct. Equals, I'm going to move this over because I want to keep this integral in. Integral of e to the x cosine of x dx. E to the x sine of x minus u equals e to the x, du equals e to the x dx, dv equals sine of x. I really should go with negative sine of x. I think that'll help me. V equals negative cosine of x. Yeah, that works. Minus e to the x, negative cosine of x. Careful here. Minus e to the x, negative cosine of x dx. This could go on forever. Let's write it properly. E to the x cosine of x dx equals e to the x sine of x. Minus minus is going to cancel, plus e to the x cosine of x. Minus minus is going to cancel, minus is going to come out front, minus integral e to the x cosine of x dx. At which point, well, let's just keep going. We'll check it out. Why don't we just move this over? At which point I usually get the, can we do that? And as I like to say, it's America, we can do whatever we want here. Don't know if that's true anymore. 2 integral e to the x cosine of x dx equals e to the x sine of x plus e to the x cosine of x over 2 plus c. Prove it. Take the derivative, see what you get. It's going to work out. You're going to get e to the x cosine of x. That's crazy math. You've been warned. They do tabular integration now, which is a mistake. I was going to delete it off, but I do have people tell me they've used it in college. We just did tabular. Long story short, we recognize this is going to take a while to reduce. X squared is going to become 2x, 2x is going to become 2. It's going to take 3 steps. We're going to have tons of space. We got problems. So they came up with this little shortcut. All right. F of x, here's your 2 functions, is x squared. G of x is e to the x. So we go over here and we say f of x and the derivatives. And over here we have g of x and the integrals. X squared, 2x, 2, and wait till you get to the 0. E to the x, e to the x, e to the x, e to the x. We connect them on a diagonal. You ever watch the movie Stand and Deliver? He does this and he calls it tic-tac-toe. Here's the hard part. There's that minus in there. So the first one is positive. Next one's negative. Next one's positive. So here's what you get. Integral x squared e to the x dx equals x squared e to the x minus 2x e to the x plus 2 e to the x plus c. Do I recommend that? No, I do not. But again, You probably see this in a math classroom if you get a 2 on my exam, and then you have to go do this. Well, might as well get used to it. It's not that hard. It's just something else to memorize that bothers people. But I don't know, maybe you should do it that way. Maybe it's easier. So let's try one. F of x equals x to the third. G of x equals sine of x. F of x and derivatives. G of x and integrals. X to the third, 3x squared, 6x, 6, 0. That's a lot of work. And sine of x is the first thing we write. Cosine of x, negative sine of x, cosine of x, sine of x. Are you sure? No, not even remotely. Derivative sine is cosine, negative sine, negative sine is negative cosine, sine. Okay, now I'm sure. So plus, minus, integral x to the third sine of x dx equals negative x to the third cosine of x plus 3x squared sine of x plus 6x cosine of x minus 6 sine of x plus c. Checking my work. Woohoo. Again, never on an AP test. Too long. Don't need this. But some people really like it. It really makes their lives easier. So if that works for you, good for you. Some final, this is where you start getting into this really crazy higher level math, where this integration by parts is, maybe it helps. How do you integrate ln of x? Well, there's only one function there. Yeah, but I need a function and a derivative, so there's actually enough for that. U equals ln of x, du equals 1 over x dx. I'm not going to look at my notes. I'm curious where this is going to go. dv equals dx and v equals x. So integral of ln of x, ln, goodness gracious, x dx equals x ln of x minus integral of 1 dx, x over x plus c equals x ln of x minus x plus c. Oh yeah, prove it. d dx of that gives me, leave it, 1 over x plus derivative ln of x minus 1. That's 1. That's negative 1 equals ln of x. So I never memorized this. I can do this if I ever need it. I've never really needed it, but it's interesting. And then this is off the reservation. I should do it in class, but I probably won't. And when we're done, we'll solve for plus c. But for now, integral arc sine x dx. U equals, of course, arc sine of x, because I don't have to take the integral of it. dv equals dx, v equals x. du equals 1 over square root of 1 minus x squared dx equals x arc sine of x minus integral x over square root of 1 minus x squared dx. Yeah, great. That helps so much. Now what am I supposed to do? Hey, use substitution. U equals 1 minus x squared du equals negative 2x dx. Dx equals du over negative 2x equals x arc sine of x minus integral. Don't know what to do with that. This is now u to the negative 1/2. Dx is du over negative 2x. On the bottom, plus 1/2 equals x arc sine of x plus 1/2. Add 1/2, divide 1/2 is times 2 u to the 1/2 plus c. X arc sine of x plus u is 1 minus x squared. 1 minus x squared to the 1/2 plus c. 0 equals, that'll be 0, plus 1 plus c. C equals negative 1, unless I'm very mistaken. I ran out of space there. Oh, naughty me in my old notes. I didn't solve for that. Just can't get good help these days. Integral sine arc. Integral arc sine of x dx equals x arc sine of x plus square root of 1 minus x squared minus 1. Double check. That's y, of course. 0 plus 1 minus 1 is 0. That's pretty slick. Why bother showing you that? That's just me going off the reservation. Well, here's why I showed you that. Talked about the fundamental rule of calculus. Everything has an integral, everything has a derivative if it's a continuous function. This shows you just how far down the rabbit hole you can go with integral calculus. How do you find all of those integrals? You do stuff like that, it's challenging. Anyway, enjoy your entry into really crazy psychotic higher level math. Good luck and happy mathing.